So hello everyone and welcome to week 16 lessons. In this lesson, we are going to go over what we did with the maternity and pregnancy registration system that we're trying to build. And then we are going to look at some important inbuilt Python functions. And we'll continue in week 17 with these functions and begin to create the functions that will do all of the functionalities of the app that we are creating. So if you look back to previous lessons, we have used the env file to provide sensitive information via an environment file. We have looked at how to use poetry to manage dependencies. And then we have gone further to start creating our models for the project. Now, because we are going to be working majorly on back end, and we're not going to look at front-end functionalities. If anything, I will do the front end and just put it in a repo for you to clone, but our focus is on the back-end functionalities, and we'll try as much as possible to use functional programming. We have created the app file, and we explained all of this in week 15. I will advise you to go back to the recording of week 15 to refresh your knowledge on what we had discussed so far. We converted our app to use function, and then we return the app here when we instantiate this function call here. And then in the models directory, we started creating models. We created a user model that will create a table in the database that will have the information for the users. We say we want to have columns for email, password, and the role. We also created the maternity registration tables, and we split that into two tables. Table for that will hold personal information that we want to de-identify, and a table that will hold other information about the client using the foreign key of the patient number that was given in the client's table. So we have a total of the users table, we have the client's table, and we have the registration info table. Now, the overview of the project is that we want to have something that someone will walk into a clinic and register for maternity. Personal information will be collected. The maternity file is going to be like the parent file for all of the subsequent pregnancies that client will have, and which means we want to have a pregnancy record. So every time a client gets pregnant, we want to register that pregnancy and collect information related to that pregnancy. If the person comes back in 5 years down the line and is pregnant again, we want to register another pregnancy, grouping all of the person's record under one maternity record. So which means that when we pull out the maternity record, we want to see all the pregnancy histories of the same person. We want each subsequent pregnancy to pull information about events of the last pregnancy, the risks that the client was exposed to in the last pregnancy, the outcome of the last pregnancy, which means that we want to have information about the birth and the labor and the postpartum information, so that will inform the next pregnancy registration and pull out this data without us having to enter the same record more than once for the same client. And that's the purpose of having an app where you make your data collection process easier, but then more complete, and we can now have data that can lead to informed decision making in the future. And also, after creating this model, let me go to my database so we can see the models that we have created. I'm going to close up some stuff, and I will have this localhost/php. So for all of you using MySQL Workbench, you know how to get there based on your lessons in part 1. So we have this users table, we have the registration info and the client, and we know the model where we created this in. We want to create a new model now. We want to call this the pregnancy registration. And so for the pregnancy registration, we also just want to register information related to just that pregnancy. Okay? And so let me come here and I'll create a new file, and I'll call this pregnancy.py. Now, to make it easy, I'll just come to this maternity here, and I will copy this, and I'll paste here and delete what I do not need. Okay. So let's start. Refer to last week's lesson to understand all of these imports and why we created all of these classes here and why we need them. For now, we do not need these classes. We might need the choices, so I'll leave it for now. And we don't need the gender identity. So let's think like a developer now. If we register a pregnancy, we want a way where we can pull all records across different tables about that pregnancy. And the only way we can do this is to have a unique pregnancy number for each pregnancy. So the pregnancy registration will have the maternity number or whatever number we use to uniquely identify this person's record, which is the patient number, which will still be the parents table, and we'll have the child in the pregnancy table that we're going to do. And then we want to have a pregnancy number. So by the time we pull out maternity patient number, we can get all of the pregnancy list of all the pregnancies and click on those pregnancies and then see information about each pregnancy in details. And by the time we want to look at each pregnancy in details and get all of the files across different tables about a pregnancy, we want to have a unique identifier for each pregnancy. So you can think about this in different ways, but we want to keep the integrity where all of the tables are linked and all the information we want, we can have a unique identifier that links the record to a particular pregnancy. So I want to create a class and I'll call this pregnancy reg, and I'll call this pregnancy registration. Let me call this preg reg like this. We will have an ID column and it's going to be an integer. It will auto increment. I'll make this the primary key. We want to have the patient number, which is going to be the unique the foreign key, and so I'll copy this from here and I'll make this patient number the foreign key. Now we want to have a column that is going to be the pregnancy number. So let's say pregnancy number. When we create our functions that is going to process whatever is entered on the front end to the back end, we might want to just have an algorithm for automatically generating pregnancy numbers that will be unique and insert. So maybe on the form, the front end form where we register pregnancy, it doesn't give a number. When you submit the form, it tells you what the pregnancy number is. And so if it's the normal hospital structure, you can now write in on the hospital card what the number or identifier for that client is when they come for antenatal for that pregnancy. Okay, so let's say we want a pregnancy number and we want this to be an int. So say mapped, or let's make it string because it will be virtual in case if it's alphanumeric. So let's make it string and we'll put map column. Let's just use let's say 20. So we now have a number that will now be a parent column for the other tables regarding the pregnancy. We want to get, when somebody comes in for pregnancy registration, we want to have the last menstrual period. So let's say date of LMP. And we want to say we are going to map string. Let's use datetime. Let's do it like this for now, and then we'll retrace our steps later. We want to do the expected date of delivery. Now, for better use of system, you are building a system this modern time. You want to automate as much as possible. And so we can leave an EDD column that will just give us the EDD, but on the front end, based on the date of last menstrual period, we want to use something like JavaScript, or even on the back end, we can use Python to automatically calculate this based on the current date plus the date of the LMP, and the EDD will always be updated in real time. And whenever the client comes, it shows that the expected date of delivery is this date. And we'll leave a column here in the event that the person's LMP was estimated, and then a scan begins to show a different measurements of the fetus, and then it begins to give a different expected date of delivery. The doctor or the healthcare provider will now be able to update the expected date of delivery. And so we'll just use this as map string. And then we will, leave it as date time. Let's enter something like type of last delivery. You want to have information about the last pregnancy. So let's say this is the first pregnancy that is being registered on the system. This client has had previous children from a different country that has never been on the system. And so you have no record of it. And you want to ask these questions and you want to save the information of the type of last delivery. Now we use string here, but one thing we want to do is we want to make this optional in the event that the person has not had a child before. So your logical reasoning needs to be up there when you do something like this, because most of the time when you get your business requirements to build an app, the person giving you this contract do not even have a full detail of what they want. Sometimes they have no idea what they want. Your research skill and your logical reasoning skill has to be there. You need to research the domain. You need to research how things are done. You need to work with cross-functional team and ask questions about how these are done. You can sit down with an antenatal nurse or a maternity nurse and ask questions of what information will you collect when you're registering someone for antenatal for a pregnancy, and what information do you get as baseline information, what information do you get down the line, and that's how you gather your information to be able to know which values are optional, which values are required, which values they must have, and which values that can be left blank. So in the events of type of last delivery, we use optional because it might just be a first-time mom or first-time expectant mom. Does everybody understand?
Yeah. Yes.
Okay. So let's say we want to have something like expected delivery. So we have the forms in the course resource that you can use. I'm using the combination of the form and any idea that just comes into my head on the fly. In real life scenario, you are going to build your app with the real complete information based on your business requirements. Okay, so let's say that we want the expected delivery facility. So the person comes and you want to, well, let's leave that last. Let's just look at everything about the last delivery. Type of last delivery, we want to get outcome of last delivery. So the outcome, we can even actually create choices here to say the child is born alive but later died alive, stillbirth, or things like that as choices here. So we can use the choices here, but for now we'll not even use choices. Let's just put a blank outcome so they can tell us what the outcome of the last delivery is. So let's not put too much columns because this is just a test app. We're not building a real life app, but you can imagine as much as possible and use the forms to edit your own columns to create as much columns. So now we want to say expected delivery facility. Again, within a country, you can have a predefined list of facilities that will be in a different database, like list of sites, and then a drop-down menu is going to pick that list, and you can now use enum here to select from that list if you want. So because we are not dealing with front end and back end at the same time, we're just dealing with how to create models and how to write function to have a fully functional back end for a front end developer to look through and begin to create the different forms for the different routes that we'll have in our functions. Okay, so we have the expected delivery facility. One thing they do in pregnancy for baseline is they might just take your, let's say, your weight and height. Let's do all those basics. Let's say vital. Let's say weight. No, let's leave this for the encounter form. Let's have an address, and then let's have risk assessments for pregnancy. So there's always a baseline risk assessment that they will do to find the behavioral risks, the psychological risks, the medical risks for that pregnancy, and the obstetric risks. So let's look at behavioral risk assessments. We can decide to stop here and create a new table we call behavioral risks. So I'll delete all of this. We can now put the date that this was filled and like date created and make it to be timestamp date sign on. And timestamp date time now. Then we want to create a new table here. We want to call this pregnancy risks. So you want to, as much as possible, break your data into different tables of related information. We just use this to just collect some information about dates and something about the pregnancy. Then we want to now use a table that just has the risks. Now we want this to be attached to the pregnancy. So at this point, pregnancy number becomes a foreign key there. So I'll copy this and change it to pregnancy number. We have the ID. I will delete all of this. And then I will have this. I'll change this to pregnancy number. So do you understand why we're having this as a foreign key? So the pregnancy number is a foreign key and it's going to be on the table. Sorry, this okay, so this is going to be for clients.patient_num, but this is going to be for reg.patient_pregnancy. So be reg.pregnancy num. So we are saying that the table name, that's the column name, that's the parent column for this. So we are making this a foreign key so that all of this assessment is tied to this pregnancy that we're looking. So when we try to get the record based on pregnancy number, it gets all of the data about that pregnancy. Is it understandable?
Yes, it is. Yeah.
Okay. So we have pregnancy number, and then we want to do the behavioral risks. Let's say smokes more than 10 cigarettes per day. Smokes more than 10 cigarettes, and we use maps choices to be yes, no, not applicable, or none. So we are using this choices class here. We can actually put all of this class in a different file and just import it, and so we don't repeat it across files. That's the most professional way to do it. But in order not to get you confused, I'll do everything like this, and then we can clean up at the end to start putting things more professionally. Okay, we don't need any of this. I'll just leave the timestamp. So one, we say smokes more than 10 cigarettes. Let's put per day, and it's map choices. We want to put less than 2 years since last pregnancy. And this will also be mapped choices. Then we have had pregnancy. No, let's have offered HIV counseling. Now, one of the standards for pregnancy is that on the first time a pregnant lady shows up at any clinic, HIV and syphilis tests must be offered. So we want to enforce that compliance and say that on their first visit to antenatal registration, they must have an HIV test and a syphilis test, and send other serology to the lab for HTLV and gonorrhea, and every STIs that puts the pregnancy at risk is usually done on the first visit. If the person's first visit is more than 3 months before the date of delivery, it is going to be done again in the 3rd trimester and closer to the date of delivery to make sure we have the most recent, so that a client who has HIV on the day of delivery will have certain injections that will prevent mother-to-child transmission. And so they need to have these results to be able to know. Now, with that knowledge, we are going to now put that information here to say offered HIV counseling. put map choices. Then we'll now have substance use in pregnancy, substance abuse, map choices. So these are behavioral risks. We are going to stop here on the behavioral risks. We can check the form and get an exhaustive list of behavioral risks that are by standard marked for every pregnancy registration. So we want to have the psychological risks. So we want to see if the person is an adolescent. I know that the last time I checked, anybody who is pregnant and is 16 years and below is flagged as high risk. Anybody who is pregnant and is 35 years and above is flagged as high risk. And so we will look at adolescents to make sure that the system has flags for the different registration of pregnancies. And so this is where surveillance or reporting starts, where you see the number of adolescents who are pregnant in a place, or the number of people who are under high risk pregnancy, whether it's based on their BMI or based on the fact that they have gestational diabetes or endocrine disorders, or they have any cardiac disease, or they have uncontrolled asthma, or they have anemia in pregnancy, or they've had 2 or more spontaneous abortions or urinary tract infections in the previous time, or they currently have an STD. So we do the adolescents, and then we want to check another psychological risks like inadequate finances, homelessness, sex workers. So let's put that inadequate finances. So let's do inadequate nutrition, inadequate finances. Domestic violence is 1. Mental health condition is 1. Inadequate finances. Some countries have programs for pregnant people who are exposed at this risk to get some levels of interventions or housing while they're pregnant. So let's say inadequate housing. So they can use this to collect data and refer them. So we want to say inadequate social support. We want to have less than high school education. Illiteracy is also a problem in pregnancy. Then poor nutrition. We have inadequate nutrition. Let's psychiatric history. We've had mental health conditions. Let's see if the person has significant learning disability. Now let's move to the medical risks so that we don't waste so much time. We want to see if the person has cardiac disease. We want to see if the person has diabetes. We want to see if the person has endocrine disorder. This medical risks, I think we would have covered it in the maternity. I don't want us to repeat it. Yeah, we covered this for conditions that the client has before pregnancy. Now let's just make this the obstetric risks instead of the medical risks, which is the conditions the person developed in the pregnancy. So let's put obstetric risks. We'll do abnormal pap smear. We have let's say anemia. Again, we are going to have an algorithm that will define the values that the system will flag as anemic based on region or country of residence, because it is known that people in Asia and Africa have a lower HB than people in other countries. So when the HB standard is 12 or 13 as normal for other countries, in Africa and Asia, HB of 10 sometimes is not even a problem based on history. So we will see how we create all of those other support tables that have this defined information, that the administrator will define what is normal and what is abnormal. And so that when it is entered, the system will compare the values that is entered into this risk table against the value that is put as normal, and we'll make it dynamic so that they can always update what is supposed to be normal and what is not supposed to be normal. So flags are generated to say this client is under high risk because the client's value is below the normal or above the normal range, and things like that. So we want to see if the person has a BMI greater than 30. And if yes, let's say BMI over 30, we put it as choices. We say gestational diabetes if the person has diabetes in pregnancy. We have history of cervical uterine infection, history of cervical uterine infections. We want to see history of infants with any infants with neurological defects or congenital abnormality. So the person has had children previously. We want to know if any of the children has any neurological disorders. So history of infants. With, let us put neurological defect. Yeah. Then let's say we want to have history of infertility. We want to do inadequate prenatal care. And then let's say we want to have incompetent cervix. We want to see, let's use IUGL. So most of these things are on the forms in your course resource that you can just use to know what you will have. If the person is carrying twins, 2 or more spontaneous abortion, and we want to see, we'll just shorten this thing so that we can move on. RH sensitization. So I'm going to do it complete and post it to a repository and send you guys the link to clone the repository. Okay. Let's stop here as all of the risk assessments we want to add to this pregnancy. So we have collected the baseline information for this pregnancy. In this pregnancy here, let's put the weight of the client. And let's put the height of the client. So we can calculate the BMI automatically. So let's make this weight to be int, and integer. We want this to be, let's put it 6 in case of decimal numbers, or let's put it 10. And then we'll do the same thing for height. And then we'll put date created here. So all these tables will be updated when we create functions that will do insert and update and that. So what we've done here is to look at the prenatal registration form and try to create tables from that form that will hold the data. And the front-end developers are going to look at the different columns in this model to be able to create form fields for the front end where these values will be entered. And then later on, we're going to create the functions that will process that values before they are sent to this database there. So when you are a back-end developer, most of the time you create a back-end and the models before even the front end comes into play in what they're going to do. Sometimes you find people who start from front to back, but functions and classes and things needs to be created, functional tested, and then front end is just to create the route. Let's see if all is well and if this will go well. We use clients.patient norm. I'm wondering if we're supposed to even import this table here. Let's just see if it works first. So we've done all of this. We'll go to the app file and we'll run this to see if all is well. Now all is well. It seems everything has been created correctly. We'll go to our web page. We'll refresh and see if we have those 2 tables created. It's not created here, and I'll tell you why it's not created. Always remember that when you create a new model, you have to import it on your app file and make the table creation here. So we've imported maternity, let's import pregnancy. And then here we want to do this. So let's say pregnancy.pregnancy-reg.table, and we want to do risk assessment. We want to create this table. Say integer takes no argument, so that's why we made a mistake here. Integer. So let's see, this is the problem, and we're going to run again. So this looks like everything has been created well. We can't find an error, but there's an error here. Raise error, can't create table maternity records.pregnancy risks, foreign key constraint is incorrectly formed. So let's go back to the pregnancy risks. Maternity records .preg risks. So what is the foreign key constraint that is incorrectly formed? So the foreign key here is the preg reg, and we want to use the column patient norm. We want to use the column pregnancy norm here. So the pregnancy norm here is map string. It is this, and it's telling us it is incorrectly formed. So why is it incorrectly formed? Now we have this patient norm here as a foreign key of the client. Let's see if that one is created first before we retrace the error. So when we refresh this, we have the pregnancy registration table created, and when we look at the structure, we have everything created here. Now this pregnancy norm, we should actually make a unique column. Let's go there and see. Now this patient norm is a foreign key here. Now we made a pregnancy number here, but we didn't make it unique. If we look at the maternity here, when we created a patient number here, it is unique equal to true. So let's do the same thing with that and see if that is the problem. So we come here and look at the pregnancy norm and change this to have unique equal to true. We will clear this and run again to see if that is the problem. And then we still have the error, which still says the same thing. Can't create stable maternity record on pregnancy, the foreign key is incorrectly formed. Now let's go back to that. We have preg risks, we have the pregnancy number. Oh, we didn't delete that table to make it so it's not going to auto recreate it. So let's just delete this table. You don't delete tables when you have data in it, right? You fix the error using alter table command, but we're going to drop the table and then we're going to recreate them all. Go back to the app file, we run, and this time we have no errors. And then we'll just refresh this and we'll see that we have both the pregnancy risks and the pregnancy reg table created. And when we look at this pregnancy norm is a foreign key. If we want to look at table relation, let's look at the relation view, or let's go to the database and look at the design. We can now see how the tables are linked. If we begin to take this out here, you will see that. Let's separate them so that you can see the link between all of the tables. So when you want to be a database designer or an administrator, and you are going to create your models, or you want to create a schema view like this to show the relationship or the entity relationship diagram, this is what they mean. So this will just show you that this maternity record, the pregnancy risks table in this maternity record database, is connected to the pregnancy registration table by the column pregnancy norm. Now there's a table behind, this is going from behind. Now it's telling us now again that the client's table and the pregnancy registration table are linked by the patient norm. So we can see that the integrity of this database is kept tight because there are links between them, and we don't have to repeat any information more than once. Does anybody have a question? Anybody has any question?
No.
Okay.
Yeah.
In the absence of question, let us quickly look at some functions that we have in Python. So I'll just create a file here that I will delete very soon, but I want you to understand these functions so that you can use them in the functional programming that we are going to do. In Python, we have several inbuilt functions. Let me just add another folder. Let's add this, and let me add this. So here I'll create a new file, and let's call this inbuilt.py. And here we'll just say if name okay. So here we're going to write our code. So we want to look at the inbuilt functions that we have. We'll start this week, and in week 17 we're going to do some more of the functions. First of all, we have discussed functional programming, and we have said that functional programming is based on breaking down a problem into a set of individual functions. Now, other core features of functional programming are like the use of recursion rather than loops. And when we say recursion, we mean that the ability of a function to call itself. Also, for functional programming, the use of recursion rather than loops is majorly for control flow structure. We also use higher order functions. We also use pure functions that avoid side effects. We also focus on what is to be computed rather than how we compute it. And we also focus on list processing. We want to look at some inbuilt functions that will come in handy. And most of your technical exams will actually give you questions that need to use this inbuilt function. We have the filter function in Python that returns an iterator. And what this does is it tests each element in a sequence. So let's say, for instance, we have a question that, given a list of strings, we want to return a list that contains all strings with 3 consecutive characters S in them. So let's say I have a list called my list, like this. And in this list, I have these strings. Let's say I have AAA, BB, SS. I have SSS, AAA, BB. I'll just do something randomly. I have BBB, AAA, SS. And then I have BBB, SS, AAA. And I have let's say DDD, the string. Let's say DDD, SS, CSS. And let's have another one. And let's say GG, SS, HH, SSS. So we have this list, and we want to write a function that will return any of these items that has 3 consecutive S. So it has SSS in them like this. When you begin to think about this thing, you are going to write some very long codes that will not be as optimized. But we have some inbuilt function in Python that help us achieve things like this. And the first thing we want to do is we want to create a function that will check for the criteria that we are looking for. And then we use a function called filter to now apply that function to the list. So when we use the filter, it will return an iterator that will test each element of the list based on the condition. So let's create that function first of all that will check this list for the criteria that we want. So let's say we call it check. And what we are passing here is a list. Let's call the list X. Since it's just a function we are creating, and when we pass the argument, we're going to define it. And what we want to return is we want to return SSS in X. Okay, so this is the function. Simple and short. What we want to do now is to print out all of the items of the list that has 3 consecutive SSS in them. So let's say we want to have new list is equal to, and then we'll say the filter function like this, and we'll pass in the first argument to be the function, which is check, which is the function we want to apply to the second argument, which is the variable that holds the list. And then let's say here we want to print new list, or let's say for I in new list, then we want to print I. Okay, so let's run this and see. So it prints SSS A, A, B, B, and this with SSS. So let's look at this. This will not be printed because it does not have 3 consecutive S. This will be printed because it has 3 consecutive S. This will not be printed because no 3 consecutive S. This will not be printed. This will not be printed, but this will be printed. So we have 2 values printed, and these are what we printed on the twin. There are other things you can use this for. This is just one simple way we use the filter function to be able to do things that you want to check a list against a condition. One of the conditions you can do is when people register on the site, you want to extract all of this from the database into a list and check and return all of the people whose age is greater than 18 or whose age is less than 18, or all of the people who spent a particular amount. You want to put them in a new list, and maybe you want to group them as premium members or just different criteria like that. You have a short method of doing this and a more cleaner way of doing this. And this is an inbuilt function we call filter. Let's look at another example of using this filter function to return all even numbers in a sequence, for instance. So let's say we have, let me comment this out. Let's have a sequence. Let's call the sequence. And this sequence is equal to, let's say, 1, 2, 5, 6, 8, 11, 14, and let's use 18, let's use 22, 34, let's use 98, let's use 88, let's use 81. And what we want to do here is to apply the filter function to return all even numbers here. We first of all create a function. We call this def, let's say def even numbers, and we'll pass the list here X. So you can use this for any sequence, not just lists, any sequence data type. And we want to say if X modulo 2 is equal to 0, then we want to return X. And here we will say result is equal to filter even number sequence. So we want to apply this function to this list to check each item of the list and return that item if it is an even number. And then we want to say for I in result, we want to print I. Okay, I'll clear this, and we expect to print only even numbers out of this. So all of the odd numbers are not printed out here. 81 is not printed out, 11 is not printed out, 1 is not printed out. So this is how we use the filter function. Anybody has a question?
No.
Okay, so I will let you know if we can have a live class tomorrow to continue a lot of these topics and do examples that will come in handy when we start building our function. So you'll get a message on the WhatsApp group by the end of the day or early tomorrow if we get a time slot for another live class, so that we can cover as much topic live as possible. Okay. So thank you, everyone, and I will make the recordings available as soon as possible.
Thank you.
Okay.